there, this is video 4.1, graphing quadratic functions. Our concepts here, a lot of this is going to be review, but in a different form. So we're going to graph quadratic functions, and we're going to find and interpret the maximum and minimum values of a quadratic function. So let's look at our first few vocabulary. I'm going to give you the vocabulary definitions, and then we'll dive right into the problems. So the first one is a quadratic function. The quadratic function has the greatest exponent is 2. Okay, so you see f of x equals ax squared plus bx plus c. Then it's got 3 terms. The first term is called the quadratic term, which has the variable with the squared power. The second term is called the linear term. It's the power of 1. And then the last one is the constant term, which it has no variable. It's just a constant. So a, b, and c are real numbers. A cannot be 0 because if it was, then we wouldn't have an x squared. Highest power would be 1, which would make it a linear equation. Also note, we were transforming these in vertex form, and we're going to learn more about those as we move along in quadratics. We're going to spend a lot of time here. But in this form, f of x equal ax squared plus bx plus c is called standard form. So the book does not tell you that, so you need to write that down and know that. You also need to know, which we should already know, that the shape of the graph is called a parabola, which is a U-shape. All right, so remember, we learned the parent function f of x equal x squared. Then we learned how to do transformations and graph it. Well, we're going to learn how to graph it from standard form, and then we're going to learn a bunch of different variations. So let's go straight into the example 1. I said f of x equal 3x squared minus 12x plus 6. So right now in this example, they want us to just make a table and graph it. So they picked some points, 0, 1, 2, 3, 4. And they did f of 0. As you notice this middle column right here, they put 0 in for x and they got 6. So the coordinate is 0, 6. Then put 1 and they got negative 3. So here are the coordinates. So they plot those coordinates and then they connect the dots, and we should see it looks like a U. It has to be a U shape. If our graph is going sideways or makes a funky curve or something, then we've done something wrong, because it's always going to be a U, whether it's going up or it's going to be upside down U. So I want you to pause and just do guided practice 1A, because this is really not a good way to do this until you learn more characteristics about the quadratic. Okay, so now let's look at the key concepts of a quadratic function. So we've got some more vocabulary here. So let's look at the next 2 vocabulary. We've got axis of symmetry, which is new for you, and we've got vertex. Okay, so the axis of symmetry, it's important to write this down. So let me give you the vocabulary. So axis of symmetry is a line through the graph of a parabola that divides the graph into 2 congruent halves, and each side is a reflection of the other one. As you can see here, the axis of symmetry is a vertical line. So remember, it's a vertical linear equation. How do we represent it? X equal some number. We'll talk about that in a second. Then we have the vertex, which is the point at which the axis of the symmetry intersects. So the axis of symmetry is going to go through this vertex, which is the peak point of the parabola. So it's going to go through this x coordinate, through the middle. You see it divides the right side and the left side to 2 even sides, and they reflect over this line. So if you fold it horizontally to the right or to the left, they're going to reflect each other. Okay, we've already done some kind of reflection. So, and you see here, here's a y-intercept, and it's going to be however many units away from the axis of symmetry. You take that and you go this direction, that same amount of points, and you can get this point over here, and you see that the reflection, this is a reflection of the y-intercept. Okay, so now that we know that, let's continue. So you can use the axis of symmetry to help plot points and a graph of a parabola. So let's look at example 2. Now, there is a formula. It's right here. You need to write this down. So the axis of symmetry formula is x equal negative b over 2a. So let's first look at the equation. So we said f of x equal ax squared plus bx plus c. So you must identify what a, b, and c are. So let's look at our equation here. Whoopsie. All right, so so on this one, oops, did they give us one? Oh yeah, y equals x squared plus 6x minus 2. So it's y equals, so remember, y is f of x is a fancy word or way of saying y equals. Okay, plus 6x minus 2, standard form. So a is 1, b is 6, and c equals negative 2. So now we're going to do the axis of symmetry, which is negative b over 2 times a, which we get negative 3. Okay, so the axis of symmetry is going to be x equal negative 3. So what does that mean to us? That means that we go to 1, 2, 3, and we have the axis of symmetry. Okay, the y-intercept is important. It's going to be c. So the y-intercept is going to be at 0, negative 2. It's going to be c. So c is the y-intercept. Because if we put 0 in for x, this is 0 plus negative 2, which is negative 2. So we're going to go to 0, negative 2, and we're going to plot that point. That's going to be our y-intercept, right? And we said our vertex is at x equal negative 3, but we have to find the y-coordinate to it. So we're going to do f of negative 3. They don't really stress that and give the importance of that. So f of negative 3, if you put it into this equation right here for x, you should know how to do that. It's going to equal to negative 11. I'm not going to do it because we don't have a lot of time for this video. This video is long. So our coordinate is negative 3, negative 11, somewhere way down here. All right, so we know that this is the y-intercept and it's 1, 2, 3 points away from the axis of symmetry. So we're going to go 1, 2, 3 points to find its symmetrical point of the y-intercept, which is going to be at negative 6, negative 2. And we've plotted the vertex, but we have to, before we can plot that, we have to put it in the equation to find the y-coordinate. So we know it's going to be this way because a is negative, it's going to open down. So then we just, we just connect our dots and we make a U shape. Okay, so the first thing we do is we find the axis of symmetry by putting in the formula x equal negative b over 2a. This is really important. Make sure you have this written down, the formula, which we did here. Then you're going to find f of negative 3. So you're going to actually, so this is the axis of symmetry. It's also the x-coordinate of the vertex. And then we do f of negative 3 and we get the y-coordinate. So this is the actual vertex. We plot the y-intercept, which is c. So c equals negative 2. And then we know it's, after we graph the axis of symmetry, it's a dotted line going vertical. It's 3 units away, so we go 3 units the other way at the same y-coordinate to find its reflection, which is negative 6, negative 2. And then we can connect the dots and make a smooth curve. All right, so let's look at example 2. So it says use this, so we've got x squared plus 4x minus 3. So first find the y-intercept. So the y-intercept is going to be c, which is negative 3. So we're going to say c equals negative 3 is our y-intercept. What else do we want us to find? The equation of the axis of symmetry and the x-coordinate of the vertex. So we're going to say x equal, so we first have to identify what a is. So a is 1, b is 4, and c is negative 3. So we're going to do negative 4 over 2 times 1, which equals negative 2. So our equation is x equal negative 2. And I'm going to go ahead and, that's also going to be the x-coordinate of the vertex, but they don't stress this, but you need to do this in order to figure out what your graph is doing. So we do f of negative 2, which means negative 2, remember it's plugged in, so it's squared, the negative squared, plus 4 times negative 2 minus 3, which is 4 minus 8 minus 3, which is negative 4 minus 3, which equals negative 7. So my vertex is negative 2 comma negative 7. So now I've got my vertex, my AOS, which is axis of symmetry, and I have my y-intercept. So now I'm going to go to 1, 2, 3. I've got negative 2, negative 7, 4, 5, 6, 7, so right here. That's my vertex. So my axis of symmetry is x equal negative 2, so it's going to go through here. So the y-intercept is 1, 2 units away, so I'm going to go 1, 2, which is right here, which is negative 4 comma negative 3. Now I can connect the dots and make a smooth curve. Now, so they want you to plot the vertex, the y-intercept, it's symmetry, axis, symmetrical point, and then they want 2 more points. So this is 0, I might pick 2. So if I pick 2 units away from 0, I'm going to go 2 units this way, so I'm going to pick negative 6. And I'm going to do f of negative 6 and f of 2. If I put those on the table, I'm going to get 9, and I'm going to get 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you notice it's way up here and way up here, and then I can connect the dots, and they're pretty close to what I drew before. So that's how you use that information to graph it. So I want you to pause and do guided practice 2A, guided practice 2, all the parts to it. All right, so now let's look at the other piece, our last 2 vocabulary, which is maximum and minimum. What does that mean? If you have a maximum value, that is the y-coordinate, listen to me, y-coordinate of the vertex that represents the highest possible value of the function. You have the minimum value is the y-coordinates of the vertex that represent the lowest possible value of the function. So the graph is either going to have a maximum or a minimum. How do you know that? Well, let's look at this key concept. So you have your equation ax squared plus bx plus c in standard form. When a is greater than 0, which all it means is when a is positive, it's going to open up and you're going to have a minimum at the vertex, at the y-coordinate of the vertex. If a is negative or a is less than 0, it's going to open down, which means you're going to have a maximum, right? Because it's going to peak out on top. It's not going to go any further than this at the y-coordinate of the vertex. So it's always the y-coordinate of the vertex will either be the minimum or the maximum. It will not be both because it goes one direction, goes on forever. So let's look at example 3. F of x equal negative 4x squared plus 12x plus 18. Is there a maximum or minimum? Well, a is negative, it's less than 0, so it's going to open down, which means we're going to have a maximum. How do we find the maximum? Well, first of all, we have to find the vertex, right? So we have to use x equal negative b over 2a formula in order to find the maximum or the minimum. Okay, so we're going to put that in. Sorry, excuse me for a second. So we're going to say a is negative 4, b is 12, and c is 18. So I'm going to have negative 12 over 2 times negative 4. So the negatives cancel out to positive. This is 1, this is 3. So we get 1.5. Sorry, we had a little power outage here. So x is 1.5. So we have to do f of 1.5 because we need to find that y-coordinate. We know the graph is going to do something like this. We know at 18 here is going to be the y-intercept. And so we know that the vertex is over here. somewhere, but we don't know where. It's going to be along this axis of symmetry, and we know it's going to do this at 18. So let's figure out where it's going to top out by doing f of 1.5. If you put that in the equation, this is example 3, we're going to get 27. So way up here at 27, all right, so we said the y-intercept is 18 and at 1.5, so we're going to go 1.5 over here to get the symmetrical point. 3. So at 27, our maximum is going to be at 27. What's a domain? Domain doesn't matter. For any quadratic functions is all real numbers, always. The range is going to be based on the y. So if it's going upside down, it's going to max out. So it's going to be y less than or equal to 27. If it opened up, it would be y greater than or equal to 27. So pause it, do guided practice 3. Now we're going to look at this real world problem, and it starts at the beginning of our book, which is on page 219. So let's read it, what's going on. So we're going to have to actually write an equation. Well, it's not going to. It doesn't like this. So we'll have to re-go into it. So we're going to have to refer to this problem at the beginning. So we had a power outage, so I'm not going to be able to read the problem to you. So look at the beginning of the book, read the problem. So basically it says Eddie's in charge of a golf tournament and maximizing this charity. He wants to maximize the charity income. So he said he charges $80, a flat fee of $80 per entry. However, he wants to do 80 players. For 80 players, he charges an entry fee of $20 per person. But he wants to do an increase of $5. But when he for every increase, he loses 5 players. So determine. So first of all, we have to write the equation. So how much should he charge? So we know that the total is going to equal to the fee times the number of entrants. So let x be the number of price increases. P of x be the total pool as a function of x, meaning the total amount of money that's going to come in. That's what pool means, not swimming pool. So we know we're going to have 20 plus 5 times the number of increases. But then we have to times 80 minus 5x, right? Because this is the price, $5 per fee increase. A number of increases, so it's anybody over 80 players because the first 80 got it at $20. And then we have to subtract out those so we don't double dip here. So this is our 2 equations. So what we have to do is we have to multiply. We have 2 binomials, 20 plus 5x times 80 minus 5x. So we have to multiply them. So we're going to do 20 plus 5x times 80 minus 5x. And we're just going to FOIL. And when we get it all set and done, it's going to be negative 25x squared plus 300x plus 1600. So this is f of x. All right. So what we have to do is we have to find the number of increases, x. So we know because it's going to open down, it's going to peak out, right? So we have to find the x coordinate. So we're going to have negative 300 over 2 times negative 25, which equals 6. So we have to have 6 increases. So how much does he charge? We're going to put it into this cost here, 20 plus 5 times 6, which gives us $50. All right, so the next thing is what will be the maximum value? So we're going to have 6 increases, right? So we need to find the what? The y coordinate. So we're doing f of 6, and that's where we put that into this equation, which when we do the math, we get $2,500 is going to be the maximum. So pause this, do guided practice 4, and we'll see you in class.